Hi, welcome to this new session of Witness. Today we're going to continue to learn how to add more features to the Witness model. So in the previous session, as you remember, what we did is that we learned to basically to gather variables with attributes. So then we can really know what is happening in the model. So a lot of things were happening in the model, but then the attribute catch the time, and then with a variable we can start creating some calculations. So we can know, for instance, exactly the amount of time that every part is really taking to each um, to each buffer. Of course, as you notice, the name of the attribute doesn't really matter. I mean, ideally we use one name. In this case, is a1 time in. But of course, this attribute can be just time in, and that's it. But just to follow the example, we are going to use the same notation. So right now, basically, what we have in this exercise is that we are in the same point where we are able to capture the the time from each part at each buffer. But now I would like to do something else. I would like to not just being able to display the data, not only able to see the data in the final report of the simulation, but also I would like to export this to an external data file. So I think that with this, we are reaching a much more advanced level of using the simulation model, especially with Witness. So how this really works? Basically, what happened here is that every part, as you know, as you remember from the previous session, goes through each buffer, for instance. Then we capture the time in, and then when the part goes out, we make the difference between the current time and the time in attribute value. So then we get the time that each part is considering at each buffer. So now what I would like to do is that whenever that happens, I would like to capture that number, because at the moment I'm not able to capture it. Actually, if we have a look to the simulation, you will see that once you run the model, you see those figures changing all the time, but it's impossible to remember which figures they were. Even if you go to the report of the Witness model, you will be able to see at the most the minimum, the maximum, and the average level. But what about if I would like to know what were all those data? So can I capture them? The answer is yes, we can do it. And for that, we need to add a new variables so that we can integrate the model with Excel. So in this case, as you can see in the slides, we have a structure to consider. Of course, the structure is very simple, and the idea is not for you to invent a new structure, but also to use this one. So I will help you. I will go through with you here, so then you can see how this can be used. So the notation, as you can see here, may seem complex, but it's really not. It's just a few sentences that we need to add into the model, and then we just need to reuse it. And when that happens, the model will be working. So the first thing that we need to do, right, is try to understand what this syntax really means. Basically, what this means is that after I do this line in the model, then I do the second line in the model, then comes this third line in the model. You can see that in the left hand side is this XL grade array, right? This is an internal function of Witness. So that function tells me that I'm going to write information into some external file. And for that, there is a specific structure that we should follow. In this case, what this says is that the first section, as you can see here, that I'm highlighting right now, tells me in which file I'm going to write it. So notice that here there is a double line here. That means that the file is going to be in the same place where the model is, right? So this is very convenient because especially under Windows structures or Windows platforms, when you put the full line, it's very easy to miss data. So that's why we have to be sure that the Excel file is in the same folder like the witness model. Then once we say which file is going to be, which means that the file has to exist already. The file is not created once the simulation is running. Then I need to tell in which sheet I need to write the data, right? So in this case, I'm using sheet 1, which also already exists. Then I need to say which column is going to be. So in this case, this particular value is going to be in column A. And because this is not only column A, but also could be the cell A1, A2, A3, and A4, here I use the count variable so that in the first time it's going to be 1. So it's going to be A1, then it's going to be A2, it's going to be A3. Now in A1, I'm going to record the first value of bar delta t b2. In the A2, I'm going to second the second value, the third, the fourth, and so on. So, and this is basically the structure. And whenever you run the simulation, if the model doesn't work or if there is any mistake, it's because probably the file name of the Excel sheet is not the correct one, the sheet might not be the right one, or maybe the cells are not well located, or maybe the variable is not in the right format. But all these things can be checked, of course, during the lab session. I'm going to do this with you now, actually. So if we remember our previous model, as is in here, let me see if I can open the previous version. So our previous model, which is just here, okay. So the previous model just consider, remember, the information from the simulation. So here are the delta time that I was wondering to capture the different values, correct? Now I would like to, for instance, if I go to the statistics, as you know, it's very difficult, for instance, if I want to see certain variables, this is bar delta 1, bar delta 2, but it's really what is really showing is that what is the current value, right? And basically that's it. So it's impossible to see too many things from those variables. I will let you see something else, which is what I want. So it's not too much that I can really do, to be honest. So I can change this. I can try to find different ways to show things, but it's very difficult. So now I need to prepare the model. So because I know that once I will create an Excel sheet and the Excel sheet should have this name, so I'm going to copy this name. So then I can be sure I'm using exactly the same name. So I'm going to do copy. Well, copy. So I'm going to be in the same folder, which is this. So the first thing I need to do is to make sure that I save the model with a different name. I can be sure this is going to be, so I'm going to create a folder which is called Excel. I can be sure that everything happened with Excel is going to be in that folder. I'm going to save this as a lab32 Excel. Okay. So that's the first thing. So now I know that whatever the change is going to be there. Then the other thing that I have to do is that I have to create an Excel file. So I'm going to open an Excel, the Excel application, which is here. And I'm going to save it with that name. So I'm going to save as, I'm going to look for that folder, which in my case should be here. So I'm here. So lab 3. Here's the folder Excel. So I'm going to put the same name so that I can be sure that it's that one in particular. So times A buffers. Well, that's my name basically. And the only requisite to save this is that the file has to be Excel 97 2003, which is this XLS. It doesn't work if we use the current version, which is XLSX. So it has to be this one, XLS, right? So make sure that you save your file like Excel 97 2003. It's just because it's the format on how it connects to the software. So I save it. So So now, as you can see here, this is the sheet name. So it's going to be in this one. I'm not going to change it, but if I would like to change it, I could do it. Then I change also the information in the model. Here I have the column A, and this is the cell A1, A2, A3, A4. So basically what is going to happen is that whenever A1 is going to be captured, it's going to be here, A2, A3. The same thing is going to happen with B2, B3, B4, C1, C2, C3, and C4, and so on. So the idea is that we should see the three buffers, buffer 1, buffer 2, sorry, 3 and 4, writing in these different columns. So this is it. I'm going to close this because the file is already created. So now what I need to do now is I need to prepare the model. So I know that what do we know is that we need to capture the position at each cell. This means that I need to create a variable count, which is going to be an integer variable. So in this case, it's going to be, if we use the example here, right? We use var count b2. So this is the name. I'm going to just copy that one. So var count b2, and that's it. Now I'm going to clone this so then I can be sure I can maintain the consistency with the name. So automatically Witness recognize that has to continue with the name. So see, so create b2, b3, and b4. I'm going to select this. I'm going to put that here. See, I can make that maybe there. Can move it there. Right. So there. And then is the count variables. So because I know that whenever a part is going through a buffer, I need to count when I mean the time, I mean the number of part that is going through. So whenever I do the action on output, here I'm going to count which is the number of the parts. So it's going to be part 1. So it's going to be the first one. It's going to be the number 1. So because the var count b2 start with 0, so the first one is going to be 0 plus 1, which is 1. The second one is going to be 1 plus 1, so it's going to be 2. The third one is going to be 2 plus 1, so it's going to be 3, and so on. See, so it doesn't really matter how many parts it will go through. That is what's going to happen. So I'm going to do the same for all the others, so then I can do that quickly. So just copy that text, then I go to this buffer. So because this one is going to be b3, just change the name b3. That way we can do the model much quicker. And then the final one is b4. So b4 here and here. This is correct. So now, look, now if I run the model, what I'm going to see is the number of parts going through. So you have 4 parts, 6 parts. So we can see where are more parts actually, you see. So basically, I'm going to use that information in order to write into the Excel file. So considering this text that we have here, that's what I'm saying. I just need to consider this same text. I'm going to copy this one, right? I don't need to create it again from 0. Of course, if you know more function witness or you read the help, you will find many other ways to do this. But I think that this is the most simple and straight way for exporting data to Excel. So in the model here, when we go out B2, now when all this happens, so I got the which part is it, I got the delta time. Then when I got all this information, now it's time to export that to Excel. So basically, you can see that the XLWrite array is immediately in blue. This is the name of the file, to be there, sheet 1. The column A is going to be for B2, and then I'm writing the var count B2 and the var delta to B2, which is exactly here. So I'm going to copy this. I'm going to click on validate. It's validated, so it seems that it's correct. I'm going to do the same for V3. So here, now I'm going to use a different column. So it's going to be column B. Basically, I need to change this for column B. I'm going to use the other counter, which is var 3, which is this one. Every part here is incrementing the part. And then here is var delta B3. Right, so it's just very simple. So let's click on validate, and it's okay. The final one is B4. Here. So now I say this is going to be column C. Now this is the column B4, which is just the one that is on top. And then the next one is bar delta t before. There you go. Validate. Okay. Okay. So now I'm going to save the model just in case. Remember, this is very important. So basically, what should happen now is that after a part goes out every buffer, immediately we'll write the time that they spend in the buffer. So once I run the model, so of course that takes a few seconds before get into writing the model. So we have, let's say 12, 13 data. So I'm going to stop just here, right? So just there. I'm going to rewind the simulation. Now I'm going to minimize this. I'm going to look at the folder where I was. Here is Excel. So here's the file that I wrote. So now if I open this, so I can see that, for instance, all the amount of time. Of course, the first part didn't wait anything, which makes total sense. Then part were waiting, more and less time. Actually, this is very interesting because, for instance, I can, so then eventually, you can do this. So you can just, very simple. So then we can edit this part. Remind that this is B2, sorry, this is B2, B3, B4, so we know how long they wait. So we can try to plot this, for instance, so then easily we can graphically see these figures. So I'm going to use this one in particular, so we can see that, for instance, the time is being increased. So I made a mistake in here, so I'm going to delete this graph. So basically, I can just um, so that's very simple. Just need to, okay, so I'm going to, let's say just the same amount of time. So I'm going to plot this. I'm going to do a graph. For instance, it could be, let me see, uh, we can do a graph, and we can do separate graph. It's really up to us what we want to do. This is B2, for instance. We can do other one for B3, or we can add more data if you want. We can start comparing. So we can select data, right? We can add one. So the series is this one, the values. Let's see, the A values are this one. No, okay. Then I can add another one, which is before, and the A values are this one. See, so interestingly, we can see, for instance, that every time a part is waiting more, but the part who's waiting the most is this one, which is B4. So in B4, they're waiting the most, even they have less parts, and the one that's waiting the less is this one, which makes sense. So I hope that you have enjoyed this video, and now you know how to write files, data on Excel files. So I'm going to prepare a new video so then you can see other aspect of Witness.